Okay, now we've built up to this point. We found determinants. We found the inverse of a 2 by 2 matrix, which is going to help us with this situation where we want to solve this system of equations using a matrix equation. So first we have to write the matrix equation. Okay, we're going to write a coefficient matrix. So we have a column for x's, basically just how it's set up here. A column for y's. Excuse me. That's our coefficient matrix times the variable matrix. Okay, equals our solution matrix over here. Okay, so we have these three matrices. This is an equation that's equivalent to the system of equations on the left. So if we were going to solve this, and we were just, this is another way of writing this. If we were going to solve it like this, where A and B are matrices, if we pretended that A and B were just numbers, we would basically say, well, let's divide both sides by A to get X by itself. Okay? Another way of dividing by A is to multiply by A's inverse. So what we really want to do is multiply by the inverse of A on both sides. So I'm going to actually slide that out because we have to left-hand multiply this A on there. Okay, we have to multiply by the inverse of A on both sides. Well, that means we have to find the inverse of A. Well, good thing we've gone over that already. So finding the inverse of A. So we need the determinant of A. Well, 1 over the determinant. The determinant is 4 times 3, which is 12, minus negative 5 times negative 5, which is 25. So there's 1 over the determinant. We can simplify that in just a minute. Okay? And then we need to flip-flop the 3 and the 4. 4, 3, and negate the other 2. So we get a negative 5 here, and a negative 5 is a positive 5. Okay, so this is our inverse of A. Okay, so as our instructions said before, as we came up with the instructions before, we need to multiply that inverse on both sides of our matrix equation. Okay. Now we're going to simplify this determinant in here as we do this, but I'm going to write down the inverse matrix. What is 12 plus 25? Is that 37? So we have 1 over 37, 4, 5, negative 5, 3, times the matrix. So we're multiplying this on the outside of this matrix up here. Okay, 3, 5, negative 5, 4, xy, okay, equals, and then we also have to, I should have slid this baby all the way over. Let's see if I can slide it over here. Oh, come with it. There we go. Get it all lined up again. Okay, and then I need to left-hand multiply that same determinant, or sorry, inverse matrix. Four, negative 5, 5, 3, 5, 3, and I have trouble writing. Whoops! No, okay. Sometimes I have trouble writing my 5s up here. All right, back to that, and then negative 24, negative 3. Okay, well, now this looks like a lot of jumbled up mess, but it's actually pretty darn nice, at least on the left-hand side. The right-hand side, who knows? But we'll get to that. This thing here is A inverse, and this thing next to it is A. If I take the inverse of any number times the number. So 4 times 1/4, I get 1. Okay? The same basically holds true for matrices. If I take the inverse of A times A, I'm going to get an identity matrix. Basically, the matrix that's 1 for matrices. So if you multiply the identity matrix times any other number or any other matrix, you get that original matrix back. So if I take the identity matrix times the matrix x, y here, I'm going to get x, y back. Okay? So that identity matrix is just, I'm going to go to the next page and show you what an identity matrix is. Okay, so the identity matrix for a 2 by 2 would be 1, 0, 0, 1. Okay, and you can play around with that if you want to, if you don't believe me, or you want to test it out to see if that actually works. You should be able to take the identity matrix for any size matrix times, for any appropriately sized matrix, times any matrix that it should multiply by, and you end up with that matrix back. Okay, so that's what the identity matrix is. We don't need to go through the whole rigmarole. Like I said, if you don't believe me or you just want to test it out yourself, go right ahead. It's pretty simple. And even if you want to try it on your own, you can multiply these two out. But I'm not going to waste your time doing that. I know that this goes to the identity matrix, okay? Because I'm taking an inverse times the original matrix. Okay, so on the left-hand side here, I have the identity matrix times xy, and on the page over, we just said that that is xy. Okay, and on the right-hand side, I'm going to leave the 1/37 for now, and I'm going to multiply the other two matrices. Okay, so row 1 of the first matrix times column 1 of the second matrix. Okay, and that should give me row 1, column 1. Okay, what is this? A 2 by 2 and 2 by 1. So we should end up with a 2 by 1 matrix. Okay, we have row 1, column 1, and then we'll multiply row 2, column 1. So row 1 times column 1, 4 times negative 24, and then 5 times plus 5 times negative 3. Okay, that's row 1, column 1. Now row 2, column 1. Negative 5 times negative 24. Plus 3 times negative 3. So 3 times negative 3. Okay, if you want to see where let's see, we're taking row 1 times column 1, and that gives us this whole string there. And then we take row 2 times column 1, and we get this entire string. Okay, and you should know that from matrix multiplication already, so that shouldn't be a big surprise. Just wanted to make sure we outline that. Okay, now to do the multiplication. Okay, so on the top one, we have 4 times negative 24. Well, that's got to be 4 less than 100, or negative 100. Let me extend this up. So negative 96. Negative 96 plus negative 15. Okay. I'm going to leave my 1/37th out front. And then negative 5 times negative 24, that has to be a positive number. And that is 120 plus negative 9. And now just simplify that. We can bring this down with it. Our variable matrix, x, y, comes down. because xy times the identity matrix is just xy. We have 1/37. Negative 96 minus 15, negative 111, I believe. And 120 minus 9 is positive 111. Okay, and then let's do the scalar multiplication. It's basically distribution. We're going to distribute or scalar multiply the 1/37 through that entire matrix. So on the top we have negative 111 over 37, and on the bottom we have positive 111 over 37, and I believe those should actually simplify pretty nice. 111 divided by 37 is 3. Okay, so this turns out to be negative 111 divided by 37 is 3, and 111 divided by 37, or sorry, negative 111 divided by 37 is negative 3, like I wrote, and then 111 over 37 is positive 3. So as you can see, this lines up pretty nice. X over y, or the matrix xy is equal to the matrix negative 3, 3. Okay, now that seems like a lot of work for a 2x2, especially after we know how many different ways to solve this system of equations, because I mean we could eliminate, we could substitute. Okay, so this is just another way, and it's a really good way if you want to use matrices and have a computer solve them. It's a good way to program that into a computer. So that is solving a matrix equation using an inverse matrix.